For today's lesson, our focus standard comes from grade 7, Ratios and Proportional Relationships, Standard 2, B and C. Identify the constant of proportionality, the unit rate, in tables and write an equation. The topic comes from our Proportional Relationships unit, Proportional Tables, and Equations. Our essential question is, how can we identify the constant of proportionality from a table and use it to write an equation? Please take a moment, pausing the video if you need to copy down the topic and essential question into your header along with today's date, set up your question column and your note column, and resume the video when you're ready to begin. So here are the steps for writing an equation for proportional relationships. First, we identify the constant of proportionality, which remember is just a fancy phrase for saying the unit rate, also represented by the variable k. So it is the unit rate between the two variables. Second, we write the equation in the form y equals kx, where the unit rate, represented by the variable k, is being multiplied by the x variable. And in doing that multiplication step, we can figure out the value of y, our second variable. So make sure you have these steps copied down, and then let's begin our first problem. Alana makes stuffed animals for a children's hospital. She can make 3 teddy bears in 2 hours. So what we need to do is complete the table based on this rate that we've been given about Alana's ability to make teddy bears and how long it takes her. And from that, we want to then identify her constant of proportionality, her unit rate, so that we can write an equation for how many teddy bears Alana can make. So I've already started the table for you. Our first variable is the hours, and that's going to be represented by x. And our second variable is the number of teddy bears that she can make, and that's going to be our second variable represented by y. So please take a moment, see if you can think, how many teddy bears would she make in 0 hours, 1 hour, 3 hours, and 4 hours, based on the fact that we know in 2 hours she can make 3 teddy bears. Pause the video if you need to think about that. Well, it would make sense that with 0 hours she could make 0 teddy bears, right? So if she makes 0 teddy bears in 0 hours, and she makes 3 teddy bears in 2 hours, what does she make in between them? How many teddy bears does she have done in 1 hour? Well, 3 teddy bears divided by 2 hours would be 1.5. So it makes sense to keep this a constant rate, right? That constant of proportionality, to keep that a unit rate, that in half that time she'd make 1.5. So every hour she makes 1.5 teddy bears. So in 3 hours and 4 hours, how many does she make? That's right. In 3 hours she'd make 4.5 teddy bears, and in 4 hours she would make 6. Can you identify where in this table we see her unit rate? Yeah, right here. Every hour she is making 1.5 teddy bears, and if we look, because the hours goes up by 1 each time, we also notice that the number of teddy bears increases by 1.5 each time. So here are 2 ways of finding the unit rate. Because we know that at 1 hour it's 1.5, and this starts as 0, 0, and continues at a constant pattern where the hours are increasing by 1, and the number of teddy bears is increasing by 1.5, we have 2 different ways. It's 1.5 teddy bears every hour. There's one more way to see it. Notice that 1 times 1.5 is 1.5. 2 times 1.5 is 3, and 3 times 1.5 is 4.5, and 4 times 1.5 is 6. So we can either look for where 1 is in our x variable and look to see what our y value is. And if we have that, and we know that it starts at 0, 0, and it increases at a constant pattern, then that's our unit rate. We can also look for a factor that we can multiply by every x variable that works to get the y variable. So I think we're ready to write our equation. Can you identify what the constant of proportionality is? And then can you write it in this form of an equation right here? Our unit rate for constant of proportionality, represented by the variable k, is 1.5. And so, using this format, y equals, or the number of teddy bears that Alana can make, equals our unit rate times x, representing the number of hours. So y equals 1.5x is Alana's equation. From this, she can determine how many hours it would take her to make any number of teddy bears. Let's try the next one. Use the double number line below to examine the 2-ingredient Play-Doh recipe. Notice that it is measured in cups. So here we're actually using a double number line, but it acts the same as a table. So right here, with 0 cups of conditioner, we put in 0 cups of cornstarch, right? We're not making any Play-Doh. If I put in a half cup of conditioner, then I would put in a cup of cornstarch. If I put in a cup of conditioner, then I need 2 cups of cornstarch. So on, the pattern continues. We could just think of this as being a box, drawing the lines between it, and suddenly we have a table. So from this table, can you identify what our constant of proportionality is? What is the unit rate? We know it starts with 0, 0, so it meets the first criteria. And if we can find a unit rate, then we can write an equation. Well, for me, right away when I saw this recipe, I noticed that in the first few values, that it looked like it was just doubling whatever the x value was. If I take half a cup times 2, I get 1. If I take 1 cup times 2, I get 2. Does that pattern continue? It certainly does. You could have also said, well, right here, when x is 1, the cornstarch is 2, so this must be our unit rate. So a couple different ways to find it, but that is our constant of proportionality. Therefore, our constant of proportionality, or the unit rate for this recipe, is 2. And for their Play-Doh equation, the amount of cornstarch we need, y, is equal to 2 times the x variable, which is the amount of conditioner we put in. So our equation is y equals 2x. Let's try our third example. So here, for our third example, we're given an xy table, and you are being asked, using one of the techniques from above, from our last 2 examples, to identify the constant of proportionality, the unit rate, identified by k, and then write an equation in the y equals kx format. Pause the video to do some work, and then resume the video to check back and see if we agree. There's a few ways to see it, but in this one it was a little bit tricky because we weren't given 0, 0. But I did notice that the x values were increasing by 2 each time, 2, 4, 6, 8, 10. And so I backtracked 2 to go back a step in this pattern, and 2 minus 2 is 0. And I noticed on the y values that they were increasing by 8 each time. So I went back 8 on the y, and that took me to 0. So 0, 0 is part of the requirements for knowing that this is proportional, so we proved that that works. I also saw that there was a common factor, that I could take every x value and multiply it by 4, and it would equal what my y value was. So in that regard, I had enough information, I felt like, to identify that the constant of proportionality was 4, and my equation would be y equals 4x, because I had just proven that I could take any x value, multiply it by 4, and that would equal my y value. So this is going to conclude our video today on proportional tables and equations. Please take a moment to make sure your notes are complete and come ready to do more problems like this in class.